Hey guys, happy President's Day. Over the weekend, I started to work on the drill press, the gift drill press. You know what they say, never look a gift drill press in the mouth. I think that's the way it goes. Anyway, I got it cleaned up the best I could without completely disassembling it. I was going to do that, and then I saw a cold rolled pin right there that holds the base to the post. So I just did the best I could and got what rust I could off of it. And I found a couple of machine surfaces actually under all that rust. I put a toggle switch, and if you can't tell, it's an on-off switch, which is really nice. So now when the machine's on, I can just look over and see what position the switch is in and tell if it's on or if it's off. But anyway, what we're going to do is, I don't know if you saw that video a few back when I was messing around with the deli slicer, but I checked the run out on that and it was horrible. So it's got to be in the spindle. And to get to the spindle, I want to see what the run out is in the spindle. So we have to get the chuck off. So here's the actual dial indicator. I'm sure it's just a coincidence that it looks exactly like a Meditoyo, but I assure you it is not. Now the base, it is, what happened to it is that this part had threads just cut right into it. This is just made out of, I think it's made out of recycled ramen Newman packets and broken communist Chinese promises. Now, so it came and I put it together and it went like that. So the threads broke off inside the magnetic base. And I'm going back and forth with the eBay seller about this, and today's the last day for them to make this good, so they're going to get some nasty feedback, which I will leave attached in the comment section if indeed I do not get a tracking number in the mail today. If I had a drill press, I could fix this very easily. So instead, I think we're going to do it the hard way and just hand drill this and tap it. Funny little story for you. Yesterday, I was trying to figure out how drill presses are sized. So I was driving home and I figured I'd use the voice feature for Google. And I Googled it and I said, what did I say? I said, how are drill presses measured into Google? And now I want you to pause this video and do the same thing. Go to Google and say that into it and then come right back. So go ahead and pause it. You didn't pause it. Come on. Just do it. I can wait all day. Wasn't that sexy as hell? So the plan is to drill this out, tap it, and then thread this. I'm gonna have to go with that diameter, I guess, because I can't really chuck this up in a lathe. I've only got a 3-jaw chuck, but I could do that if I had a 4-jaw chuck. And let's just hope it doesn't break off right here. If it breaks off right there, I'm going to have to drill through it and tap the whole thing. So yeah, I totally agree with the theory about, buying the best tools you can afford. It's just that I can't afford the best tools. So we're going with an M11 by 0.75. It's cutting really easy. That metal is very soft. Feels kind of like threading aluminum, or even softer. Somewhere there's a drill chart, I'm sure it's in the machinist's handbook, about what size hole I need to drill to thread this. I'm just going to fudge it. I don't have a set of metric bits, so we're going to go with a 25/64 and see what happens. Well, that sucked. I went with a, let's see what size bit this is. Uh, 13/32. And I was worried I was going to break the tap. I don't know how well you can see any of this, but did a number on it. Looks like it flattened out the teeth. I have no idea what they made this out of. Yeah, let's see. Alright, so it does fit. Let me get this together and then we'll get back to the drill press. Alright, I wasn't able to get that in there very far, but I'm certainly not going to force it. It's in there, it's doing what it needs to do. And I'm going to turn the spindle from the top and we'll look at the run out. So it is way out there. So this gauge is 0.01 millimeters. And it's doing about 18 of those. So it is in the spindle. And here's the chuck. I got it off and I cleaned it up as best I could. And you can see that spindle has seen better days. So apparently what's happened is somebody got a workpiece stuck in it and it just pulled it around and bam, hit on that and started to spin. And then you can see that after it might have pulled the chuck off, and this was full of grease, the spindle, and in here. So and you can see where somebody's been hitting it on this end with a hammer, obviously, to try to get that back on. I do have another chuck ordered, but we're gonna put this one back on here, see if we can't get that run out of it. We might have to fine tune it when the other chuck comes in. Okay, now I think what we're gonna try to do is find the run out on the end of it here Now I've got a piece of drill rod, half-inch drill rod, that I'm going to indicate with, but it's not here right now. So the idea is to find the run out and strike it with a hammer on the opposite side. So that's what we're going to do after we find where the run out is on here and mark it with a Sharpie. I'm going to indicate it on this bevel because I'm going to be whacking on the other part of it with a hammer, and I don't want to put indentations in it where I'll get a bad reading. So we've got our high spot marked on 36. Now more than likely what's going to happen when I hit this thing with a hammer is that the chuck is going to fall off. I have no idea how hard I need to hit this thing, so we're going to start off light. Alright, 3 hours later. Actually, it wasn't that bad. It's a lot better, but where I've been hitting the chuck with the hammer has kind of buggered it up. And when I get the other chuck in and the drill rod, I can use the drill rod to center it up better, so I'm not actually beating on the chuck. Alright guys, that's about it for this one. Later.